Welcome to our today's lecture. We are still continuing with set theory. Set theory is quite wide. We are done with the basic definitions, we are done with the set operations, and now we have an algebra of sets. This algebra of sets simply means there are basic laws that operate in set theory, or that we use when operating in set theory. There are several, we're not going to prove them, but you just need how to state them. These are laws in set theory. You know, like the same way Kenya has laws that govern the smooth operation, it's the same way in math that set theory has some laws that are used. Our first law is called the idempotent law, and our idempotent law states that if you intersect A and A, you're going to get A. And if you get the union of set A with itself, you're going to get A. For instance, let's say you have set A has elements 1, 2, 3. If you are to take the union of A by A, you are still going to end up with set A. Same to intersection, you are still going to end up with set A. That's the idempotent. The next law is called the commutative law. The commutative law states that A union B is the same as B union A, meaning that the position of A and the position of B don't matter. Position of set A and set B don't matter. Whether you begin with set A or you begin with set B, the product or the union or the intersection will always be the same. Same to A intersection B is the same as B intersection A, because basically we are dealing with the elements in a set, so the position really doesn't matter. And now we have the associative law, saying we are given 3 sets, A, B, and C. This associative law says that if you have A intersection B intersection C, it's the same as saying that now we have A intersection B in bracket intersection C. Same to union. If you're going to have A union into bracket B union C, our associative law says that it's the same as having A union B union C. Next, we are going to have our distributive laws. All these laws can be proven, but we're not going to prove them. That is left as an assignment for the reader. The reader can go ahead and prove all of them. Distributive, as the name states, it distributes. So we have 3 sets, A, B, and set C. Then if we have A union B intersection C, it's the same as A union B in bracket intersection A union C. You see, it has distributed. A union B in one bracket, intersection A union C in another bracket. Then we have A intersection B union C. As the name states, it's going to be a distribution. So we're going to have A intersection B union A intersection C. And then lastly, we have De Morgan's law. You can see this De Morgan's is somebody's name, meaning that this law was invented by De Morgan, a man named De Morgan. For 2 sets, A and B, we have 2 sets, A and B. Then A intersection B complement is the same as complement of A union complement of B. And now if it were the other way around, A union B complement, it could have been the same as A complement intersection, B, complement. So those are the 5 laws that are commonly used in set theory. All these laws can be proven, but now because of time and other factors, I'm going to leave them as an assignment. Let me just write here. In pure math, we say proof is left for the reader, and if the reader is unable to get the proofs, you can always comment on the video, and then I'll give you one proof as a direction to help you figure out the rest of the proof. Thank you, and let's meet in our last section of set theory. We are going to handle one real life problem of set theory so that we can see how set theory is applied. Thank you and bye.